Hey, good afternoon, everyone. Don Gillis here with Chemours. I'm at the Jackson Systems headquarters in Indianapolis, in Indiana, and we're going to briefly go over some A2L information that's important to the contractors. Today, it's going to be very high level, but we're going to get down to what you're going to see in the near future, in the trucks, in the field, and those kind of things, and hopefully you'll see something that you didn't already know, okay? Again, I'm Don Gillis, been in the trade approximately 31 years or so, 24 of those years in the truck. I'm still a licensed journeyman in Fort Wayne, Indiana, and I'm from Ohio. Some of the things we're going to touch on today is this. We're going to talk about who is Chemours briefly, who are we? It's not a household name just yet. The AIM Act, A2Ls versus A3 refrigerant flammability. Obviously, A2Ls I'm going to refer to as the new kid on the block, if you will, okay? A2L safety and handling, and then we're going to talk about A2L tank design, and then also give you some educational resources that might help you, benefit you down the road, okay? So as far as components, I get this question all the time, what's changing? So what's changing, honestly, is not a whole bunch. What you're going to see is the coils, the metering devices, your compressors will be stamped now or say that they are A2L approved or certified. That's what you're going to be looking for. And when we get into tools and those kind of things, the same is going to hold true for that also, okay? So who is Chemours? Well, Chemours is a spinoff company of DuPont as of 2015. We're on the stock market as CC. What used to be Freon brand, trademark name, owned by DuPont, we now have that trademark name. What we're going to be focused on today, the lower GWP refrigerants, some of it mildly flammable. You'll start seeing the brand name Opteon. So Opteon is the new Freon trademark name. When you see the box Opteon, you'll know that that's just a lower GWP refrigerant, okay? The innovation of refrigerant, real quick, I want to touch on this just a little bit. Obviously, in the 30s, we had CFCs. R12 would be a good example. 1950s, we looked at R22. And then we fast forward into the 90s, we got into HFCs like 410A. We're going to talk about primarily comfort cooling today in this episode. When you look at all of those, you'll notice at the bottom it says ASHRAE 34, classification A1. The A is the toxicity, the 1 is the flammability. I'm going to touch a lot more on that later, but just to let you know now, A is a non-toxic, 1 is a non-flammable or low flame propagation. And then to the right, where we're moving to for the lower GWPs now, will be still no ozone depletion, lower GWPs. You're going to see an HFO or an HFO blend likes. If you're not using industrial refrigerants, you'll see this kind of refrigerant in moving forward. Again, the A is non-toxic. The 2 will be considered mildly flammable or low flame propagation, okay? So I'm not going to spend a lot of time on the chemical side of it, but I do want you to understand. I see a lot of trainers out there speaking, oh, it's an olefin, and that's kind of, everyone's starting to understand that, the HFO, hydrofluoroolefin. But what is an olefin? So the HFO molecule would be an example over here. Here's an HFC molecule. The HFO molecule, and again, I'm not a chemical engineer. I speak mainly to contractors and wholesalers, but I do know enough about it to explain it to the contractors. If you look at this blue circle right here, that is the olefin by definition. And the olefin by definition is 2 carbon molecules bonded together. They refer to it as double bonded carbons, which helps it break up easier in the atmosphere. For example, 134A, commonly used in automobile industries years ago. 14 years in the atmosphere, okay? The GWPs are approximately around 1,400, somewhere thereabouts. 1234YF, Chemours molecule, HFO molecule, is approximately 11 days. GWP of 4. Big difference there. 9 out of every 10 cars made today, in fact, have 1234YF in them. So to ease your pain or to remove some of the fear mongering, if you will, the 1234YF is in 9 out of 10 cars today. And think about that, where that's at. The air conditioner's up by the engine of the actual automobile. So just to give you an idea, the gasoline is actually more flammable than the refrigerant itself, obviously. But if you've worked around, some people don't even know they're already working around A2L refrigerants. That's why I use the example of 1234YF in automobiles, because a lot of people don't realize that that's a mildly flammable refrigerant. Okay. Also, if you bought a window unit or installed a PTEC unit recently, you've worked around A2Ls. R32 commonly, a lot of that stuff is Asian driven, like mini splits, and you'll see R32 in that equipment. They just don't make a lot of that stuff in the US anymore. So you probably didn't know it, but in the last 5, 6, let's say 7 years possibly, you've been working around R32 and grabbing it, okay? 454B is something we're going to talk about today. 454B, I think all the OEMs, with the exception of one possibly, is going with Chemours brand 454B, which will replace 410A in the new equipment. Okay, we can't mix and match them. One's A2Ls and the other one's A1s, and I'll touch a lot more on that. Meets regulatory requirements. No ozone depletion. Again, GWP is at 466 or 467, somewhere thereabouts. It's mildly flammable, close performance to 410A, and it's compatible with POE oil. In fact, the POE oil for our 454B is going to be a POE 32, which is ironically is the POE that we use in 410A today. When you get into the R32 compressors, you're going to see a POE of 46. R32 by itself runs a little warm on the discharge line, so they're going to use a higher viscosity of oil in that. So it's a POE 32 on the 454 compressors and the 410A compressors, okay, like for like. So no difference there. Let's talk a little bit about ODP versus GWP. Ozone depletion is back when we all took our EPA cards. That had to do with the Montreal Protocol. It was about the ozone, the hole in the ozone. That's what the battle was at the time. This is an actual picture of the ozone from NASA in 2008. I often I like to leave on a good note or a feel-good story is this ozone, if I was to put my index finger, is about the size of my index finger now. It's really closed up. It's a really good story. I think it's in the 90%, and they've already set a date to where that'll probably be fully closed. That had to do with the Montreal Protocol. This was a phase-out of ozone depletion chemicals with chlorine in them. Chlorine was the big factor there, okay? Moving forward, now we're talking about global warming potential. ODP, ozone depletion potential, GWP, global warming potential, okay? Two different things. Now we're talking about heat trapped in the atmosphere, okay? And basically what I talked about earlier about how long it stays in the atmosphere, the Earth has this atmosphere around it. Think of it like a bubble, if you will. It's there always, okay? When we get these emissions from different things that we use on the planet, that atmosphere starts to get a little thicker and thicker and thicker. So obviously the sun is radiant, okay? We put the radiant heat, hits the Earth. You know how radiant heat works. It doesn't heat the vapor. It hits a mass of some sort, whether it's my body or this table. Hits the Earth ever so slightly. A small portion of that bounces off the Earth. What's happening right now, because of the thickness of the layer of the atmosphere, it's trapping a little more heat than we like, hence the term greenhouse effect, okay? So most everything out there, including CO2, has a GWP, okay? It's just a matter of, does it break up in 4 days or 44 years? Really, that's what it's all about. We want to disperse that a lot quicker and lessen that atmosphere, the thickness of it, if you will. I think of the ozone depletion, I think of the ozone as Earth's sunblock, if you will. Here, I think about a car sitting out in a parking lot, as someone explained to me years ago, and the sun's coming in on the windshield. Same air outside as the same air as inside, but that air inside the car coming to that windshield is getting much, much hotter with the windows open. We crack that window, we release that air. That's kind of what we're trying to do here in the atmosphere, release that, disperse some of that heat off the Earth. And this isn't just our industry, by the way. There's a lot of HFCs that are affiliated with a lot of things, whether they're fire extinguishers, solvents, all kinds of things out there. The same as it was for ozone depletion too, okay? GWP, again, is a phase down. It's not a phase out. And I'll walk through that ever so briefly with you on the step down of that, okay? This is a schematic that I've used before at my prior position. Not to get in the weeds, but global warming potential, by definition, is a measure of how much energy the emissions of 1 ton of a gas will absorb at a given period of time relative to the emissions of 1 ton of carbon dioxide, or CO2, okay? So everything's a ratio off CO2, and CO2 has the number 1, okay? It's 0.4% of the air we breathe, so everything's based off of that. So This is if you want to get down the weeds the way I teach, because I teach so much, I kind of keep it simple because I'm not a chemical engineer, I'm not a scientist, and I speak to mostly contractors, which I am. And really, all we're really trying to get to is to be able to have that conversation of where they plucking these numbers from, okay? And where they're getting these from is a ratio off CO2 with the number 1. So let's say, for example, 410A has approximately 2,000 GWP. Let's put it, I'm going to use this analogy for simplicity reasons, is it takes 2,000 pounds of CO2 to compare to 1 pound of 410A. So it's a ratio. So whatever that GWP number is a ratio off CO2. It's CO2, the equivalent of the relative emissions of 1 ton of carbon dioxide, okay? What you see here in green is A1 classifications. The pink blocks there you see are A2L, mildly flammable refrigerants. And then you'll see the A3s, which is propane, and then the brown it would be a B2L, which is ammonia, okay? You can also see the refrigerants on the right-hand side here. 454B, GWP of 466. We have R32, 675 or somewhere thereabouts, okay? Notice the arrow here at 700 mark for the refrigeration side of things. That's what the AIM Act has give the maximum GWP of any refrigerant used in air conditioning or comfort cooling, if you will, okay? A couple slides on the American Innovation Act or the AIM Act. This is what's driving it all. Okay, the AIM Act isn't for any other countries. It's not for Mexico. It's not for Canada. It's not for anywhere on the face of the earth except the United States. It's the American Innovation and Manufacture Act, or we're going to refer to it moving forward as the AIM Act, okay? And what does the AIM Act do? What it basically did was it gave the government gave the EPA the power to basically create the regulations for a phase down of HFOs. In the following ways: establish a national CO2 equivalent baseline and issuance of allowance of production and consumption of the HFCs. So the AIM Act is a 3-step process. We're going to talk about allocations, and then we're going to talk about segments, and then we're going to talk about the third phase, which gets into reclamation and some of the tracking devices and what have you, okay? And here it is. The allocation program is the first step, which already went into effect in 2022. And basically, I'll show you a slide after this one. It shows the step down. The goal is to be down to 85% of what we were using from 2021 down to 2036, in 15 years down to 15%. And again, it's not a phase out, it's a phase down. So anyone that's been in the industry can probably already tell that reclamation or reclaiming refrigerant is going to be very, very important in moving forward. We've always said that in our industry, but I've seen numbers of how much reclaimed refrigerant actually comes back out compared to what's actually sold, and it's really astonishing. So we really need to work on that. I'm guilty of it too, but just be aware of that. It will be worth reclaiming your refrigerant, keeping it, recycling it, returning it in. You'll see a lot of people get into that market. I'm guessing in the near future that aren't in the market right now. Taking back your refrigerant will be worth much, much more than it used to be, okay? So here's your step down, your allocations. When I talk about allocations, I'm talking about Chemours and our competitors on how much they can manufacture. So they have to kind of pick and choose what they want to use. They're allotted so many GWPs, and if they want to make this or that, and I'm talking about fire extinguishers, that kind of stuff, fire deterrents, solvents, they have to choose what they want to use. Obviously, the things with the higher GWPs, probably not so much. You'll start to see those kind of phase down quicker than something with a lower GWP, because you can obviously manufacture more. Sector control limits, as I talked about earlier, that's going to be your applications. It's going to be the different solvents, fire extinguishers, all the different things there, what that looks like. And I'm going to stay away from this one today. It's the third step will be a USA reclaim program, and that gets into a lot of different things. Right now, it's in litigation. It's kind of going back and forth, and there's talk of going to reusable or refillable tanks. That may very well happen. The goal was to have that ready by 2025. They're not going to make that deadline. The best I can say on that one is just stay tuned for the future, what's happening. We're all waiting, anxiously waiting to see what happens there. So this is that graph I was telling you about. The numbers actually came from somewhere around 2011, 2013, but it started in 2021. It was actually signed in a bill in 2020, December 27th, by the Trump administration, and it was finalized in 2021 by the Biden administration. So there's no real politics here. It's all being driven by the EPA. They are the authority. The government has given them complete authority to do this. It's all on them. Okay, they know more about this than anyone who's in the office of any office. So 2021, we're at 100%. That's our allocations. Whatever we were manufacturing at that given date in 2021, okay, that's our starting point. All right. Again, those numbers are actually coming from earlier, 2011, 2013, somewhere thereabouts. But our starting point is 2021. In 2022, we had a drop in 10% of whatever the baseline was. So whatever the manufacturer was making at that minute or that second, it's a 10% drop of that in 2022. And some of you might have seen some changes in the industry of refrigerants, possibly at that 10%. The one we're looking at now is 2024. That's going to be a 30% drop, which means by 2024, we'll be 40% less manufactured than we were making in 2021. So keep that in mind. That's going to be a big change. The residential, light commercial, and the AIM Act, the manufacturers will be told up, are going to start producing A2L equipment by January of 2025. The EPA, that's part of the AIM Act. You'll see you'll see some of that transition happening, maybe even in the fourth quarter of 2023 this year, and definitely by first quarter, second quarter, third quarter, fourth quarter of all the OEMs will start to issue in their new equipment. It'll be something similar to we saw in with R22 to 410A. You'll have different assembly lines running two different types. So you'll still have that equipment, and then on the product itself, the air conditioners, those kind of things, there'll be a sell-through date as of now to 2026 from that 2025. So they can produce up until 2025, sell-through date to January 2026. But as you know as well as I do, if they waited till January 1st of 2025 to try to start producing A2L equipment, there would be a huge back order. So be looking for that. Whatever brand you sell or work with, you'll start to see that. So this is really coming really quick. You know, the transition from 22 to 410A, for me, being in the field at that time, like I said, I spent 24 years in a truck. The transition to me is very similar to what we're seeing now, but there is some differences. And the biggest difference for me is there's a shorter runway. It's happening much quicker. As far as those pressures like 410A we saw from R22, we're used to those already, okay? That's not going to change. The pressure temperature charts you're going to see are very, very similar, okay? And a lot of these refrigerants that are in these blends right now, they've already been used in other applications. It's just a different blend, if you will. So I'll talk more about that as we move along. This is just a part of that sector controls on that second step. This just shows you the different sectors we were talking about. You have fire extinguishers, foam, solvents, aerosols, transport refrigeration, all kinds of air conditioning. The biggest section of that is your residential AC, okay? So I think I saw recently how much percentage of refrigerant is used today that's purchased at the wholesalers that's just used for topping off. So we really need to, all of us, included myself, we need to do a better job of repairing those leaks, of a known leak, and repairing them, and do a better job of recovery, okay? So we'll all work on that together. Finally, on the sector control, this will be published and finalized in October of this year. So it's right around the corner in 2023. And it provides clear guidance for the OEMs, the original equipment manufacturers, and it'll usher in a wide-scale adoption of A2Ls, HFOs. That's why there's such a buzz right now for A2L training. I mean, 6 years ago, I don't think I'm over-exaggerating, my prior job, we were talking about A2Ls and all these other refrigerants, and it was like a deer in the headlight look. Now, everyone is seeking this training right now, and that's why I'm here today with Jackson Systems, to get the word out and try to defunk some of this misinformation, if you will. A lot of information out there. Most of it's good. Some of it's still, you don't know what you don't know. AMAC Part 3, again, I'm going to stay away from this right now because I want to focus on what we do know. And right now, with this in somewhat of litigation by several different organizations, I'm going to stay away from it. But just stay tuned on that. It's going to get into reclamation, QR codes, tracking codes for the tanks, refillable, reusable type tanks, similar to what you use for propane, for example. So we'll talk more about that on a different date when we have definite information on that, okay? Refrigerant classifications. How do they get classification? Well, it's tested by a third party. It's done by the American Society of Testing and Materials, or ASTM. Okay, it's not done by Chemours. It's not done by ASHRAE. ASHRAE classifies it after they get the results from the American Society for Testing and Materials. Okay, so what does that look like? Over here, you'll see the numbers go up. The higher the number, the increase in flammability. At the bottom, you'll see increased toxicity. So A is non-toxic, B would be toxic, okay? So these are the numbers, or the A1 classification is typically what we've used in the past with everything we do. Whether you're in refrigeration, using refrigerants like 404A, or in comfort cooling like 410A or R22, those were A1 classifications. That's what we were used to. Now keep in mind, Europe and Asia are way ahead of us in this. I talked about earlier, you're already around it. Whether you're working around or not, you don't know. But in your automobiles and also your PTEC units, your window units, so you may have it in your house or a motel or hotel that you're staying in with the PTEC units, you just don't know it. Actually, at the risk of being slightly off, this is what I refer to as the new kid on the block. Let's say, for the sake of not arguing, less than 10 years or so. So it's very, very new to the U.S. Obviously, it's moving forward. Canada's getting ready to move into it. We're communicating with them quite a bit with our co-workers up there in Canada right now with this new A2Ls. So be on the lookout for that right now. This is what we're moving to. Again, you're going to start seeing that equipment as early as the fourth quarter of this year with some OEMs, and definitely by the first quarter of 2024, okay? A2L refrigerants are non-toxic and mildly flammable, okay? They're still non-toxic. They have a much lower GWP than commonly used HFC refrigerants and have a lower flammability than A2 or A3 refrigerants. Again, A2L, we don't see it much in refrigerants. It is a chemical, and I'll show you some examples of that here in the next slide or two. But A3, there's a lot of misconception that there's hydrocarbons in A2Ls, and that's just not true, and I have a slide specifically that just states that. Okay, so classification 1 we talked about. Okay, refrigerant does not propagate a flame. 2, refrigerants have a lower flammability and faster flame propagation. The burning velocity is greater than 10 centimeters per second. That's how it's defined as flammable. And then you get into highly flammable, which is an A3, okay, or a 3, okay, would be like your propanes and your butanes. I purposely passed by the A2Ls because, again, I refer to it as the new kid on the block. When they had the 1, 2, and 3, when they went to go test the A2Ls or the HFOs and HFO blends, they saw the way the flame crested, if you will, across that perimeter or that 90, that V, and they had to reclassify it because it wasn't as flammable as the classification of 2, yet it wasn't a 1. It had a little higher flame propagation, mildly flammable. So they entered the letter L, which is low flame propagation, and I'll talk about that more. Examples of that would be R32, 1234YF, and it's less than 10 centimeters per second, okay? Low flammability risk on A3 refrigerants compared to propane. A2L refrigerants have much lower flammability, as I discussed already. Higher, lower flame limits. That's key. Lower flame limits is really, really key. It's where the concentration of air and refrigerant blend together, that perfect concentration to where something can ignite. And I'll show you a little bit more about that on a few slides here. So again, going up, we have the higher flammability. Okay, we've added our toxicity here. Our A's are non-toxic or low. I like to say low toxicity because, quite honestly, I don't want to get in the weeds, but enough parts per million of a lot of refrigerants, including CO2, will asphyxiate you. So use good practice when you have to and you're at a confined spot. Always use some type of ventilation there. That's just a word from me. Okay, go to the right, we're talking about our toxicities, okay? So in this case of B would be toxic, non-flammable. A2Ls, non-toxic, mildly flammable, also B2Ls. Fun fact is ammonia actually used to be a B2. And because of this new classification, A2Ls, the ammonia folks saw that classification and said, well, if that's an A2L or a 2L, then we should be a 2L. And they actually moved ammonia to a B2L because of the low flame propagation, the mildly flammable. Okay, so how do they test this stuff, Don? Here's how we do it. It's in a glass flask. This is a glass flask here. We have a rubber stopper on the top of it, okay? We have a magnetic stirring mechanism at the bottom, let's say, blending that all up, the concentration. We have an electrode that we're gonna light. As soon as the concentration we get where we think we're dialed in right, we're gonna add just the right amount of air with the blue arrow. On the other side with the green arrow is just the refrigerant. So it has to be a perfect concentration for it to ignite in between that window of lower flame limit to upper flame limit. In that window is only where. So too much air or too much refrigerant, vice versa, it will not ignite. It has to be, the planets literally have to line up perfectly for that concentration. I'm going to show you A2Ls, how high that lower flame limit is compared to like something like R290. Okay, so we get that concentration. It has to stay between this V or that 90 degree, okay? As long as that flame stays inside that V or that 90 degrees, we're classified as an A1, okay? And that's business as usual, all right? So that's what the A1 looks like. When they started testing it, you'll see moving forward what the A2L looks like. I want to quickly just look at 410A and what that blend is made of, the two components. We have half of it, 50%, good old R32. The other half is R125. Now, if you don't know, as I said earlier, you're going to have a higher viscosity oil, 46, and the POE 46 for the R32 compressors. Again, that has to do with that running a little hot warmer. The R125, 50% of it actually is part of that reasoning there. It's there to keep that discharge line a little cooler. Okay, it's also a fire deterrent. Okay, and so you see a lot of R125 or R125, excuse me, in like fire extinguishers and those kind of things. The sad part of it is, the unfortunate part of it is for the EPA's eyes, anyways, is we have 2,088 GWP on 410A. 1,400 of that, or approximately, is the R125, so half of it. And all it does is keep this down. For example, the temperature difference between 410A is right around 182, 184. On a good running R32 unit, for example, you're around somewhere around 208, I believe, somewhere thereabouts. So you remove that, okay, and you lessen your GWPs a lot. So we're going to use 454, the replacement for 410A now in most all residential, light commercial, comfort cooling. Okay, you're going to have almost 70% of still R32 in it. Okay, and then we're going to use the molecule 1234YF, the HFO molecule. So this then now becomes an HFO blend, all right, because we have an HFO molecule, even though it's that small of 30% of it. Remember what we were using in our cars, 1234YF, had the global warming potential of 4 compared to 1,500 on the R125. That's a big change. It's 78% less of a GWP. So with just the change from 410A to 454B is a 78% reduction. Think about that. Everyone has air conditionings or light commercial, like the building I'm standing in now. It's nice and cool. Just think of that alone. Just the new refrigerant for air conditioning or comfort cooling alone is a 78% reduction in GWP. That's really, really huge. Okay, it's a balancing act. We lower the GWPs, we raise the flammability. Sometimes those chemicals that we move that are keeping it from being an A1 classification or non-flammable, unfortunately, then when we remove those things with high GWPs, they then become flammable or mildly flammable. Okay, so let's look at an actual picture. A1 flame speed less than 90 degrees indicates no flame propagation. Okay. When we go to the A1 classification, these are actual photos from the lab, lights out in the chamber. They take the picture. This is a normal day, A1 classification. It stayed inside that V, if you will, that 90 degree, okay, classified as A1, okay, and this is what the testing looks like when they send it to ASHRAE. ASHRAE 34 standard is what classifies this. Here's what it looked like when they went to go test A2Ls. Not a huge difference. So now they're scratching their head going, wow, that's not a 2 and it's not a 1. In fact, if you were doing testing an A2, it would be somewhere about here. So it's much more flammable. Again, that 10 centimeters per second, greater than or less than. That's what separates an A2 from an A2L. Okay, so it just broke the crest, and that's what they use as the guidelines, is that 90 degree. So therefore, that's when the classification became a 2L for lower flame propagation. Okay, A3, obviously a much more exciting day at the lab. Propane would be an example there. It's very similar, almost exact to what the propane you use in your grills in the backyard. Much more pure on the refrigeration side. No stench. Because of the impurities and those kind of things, a lot of the different, much more pure of grade of propane for the refrigerant. But the big trick there is, again, highly flammable, not low flame propagation, and there's no stench to that. So that's kind of a slippery slope we have to be careful with, okay? a snapshot of what this looks like. I'm just going to touch on the bottom. I'm not here to beat propane up. Propane's a good refrigerant. Hydrocarbons are a good refrigerant. There's a move to get higher milligrams right now in the U.S. Right now it sits at 150 grams maximum in a unit, which is about 5.2 ounces. There's a move, and it's been passed to 500 grams and 300 grams. 500 grams will be like open cases in refrigeration. The 300 grams will be anything with a door or drawer on it. Obviously, for reasons if you get that trapped in there. Again, it's a highly flammable refrigerant. Okay, so, but to give you an example comparison to, because a lot of times when people say, we're going to talk about flammable refrigerants, they put it all in one basket or bucket, and that's not the case at all. It's apples and oranges, completely apples and oranges. And I love the industry, but sometimes I see people, we're going to talk about flammable refrigerants today, and when they start talking about them, they don't separate the two. So what does A2Ls look like? A2Ls, I made this little graph. It's kind of a generic. The lower flame limit on A2Ls, let's say 454, for example, is 297 for 454. The higher that LFL is, the lower the risk. Look where propane is. So in other words, what you see in the orange is that window between lower flame limit and upper flame limit. Anything outside that, too much air, too much refrigerant, it will not ignite, okay? So much, much less. 297 compared to 38. The higher that number is, the less the risk is. The higher it moves up, okay? Anywhere in the blue there, it doesn't ignite. So simply put, outside the range of UFL or LFL, the mixture cannot be ignited. Okay, that is what the LFL is. Now, minimum ignition energy, what does it take to do that? These are in millijoules. What does it take to ignite that? Does it take me just rubbing my feet to ignite it with some kind of static electricity, or do I need a torch of some sort? And that's kind of the comparison between A2Ls and quite honestly, propane is the example we're using here. The millijoules on that, the MIE for 454B is somewhere between 100 to 300, where it's 0.25 for propane. So we all know what propane does. We've been using it for years. Some people even use it with stoves, cooking stoves. I've converted many, many furnaces over to propane and ran many of propane lines up to homes and stuff. Propane is heavier than natural gas. I was telling some folks yesterday or this morning that when I was licensed and doing my installation out in the field in my younger years, when you ran the gas line for propane up to a home, from the LP tank, by the building department, you would focus on the windows below. So if you had a basement, you were 6 foot and diagonally from that window below. Propane drops. It's the same weight of CO2 as a solid. So when you see those Halloween parties, CO2 solid is a dry ice. You put it in that warm water, those vapors stay low. It's the same weight as propane is. It stays low to the ground. On the other hand, if you're dealing with natural gas, those kind of things, you're looking for the 6 foot diagonally of the window above. It rises versus air. So it's like, for propane is like 1.52, I believe, versus the weight of air. So the MIE is defined as the minimum electricity energy takes to ignite fuel-air mixture. Okay, what does it take to ignite it? All right, burning velocity, the speed at which a flame propagates relative to the unburned gas, the burning velocity. How fast does it go? 454B, okay, 5.2. Propane, 46. The lower the number, the lower the risk. And last but not least, heat of combustion, okay, and is the amount of heat that's released, okay, the combustion of period of a specified amount. Again, very, very low on the 454B compared to propane, 46.3. Again, kind of redundant, but the lower that number is, the lower the risk is. So I know that took a while to get there to look at it, and I don't want to beat R290 up, but I do want to make sure contractors understand that, because I travel quite a bit with my job and my last job, talk about refrigerants. I used to talk about compressors. We're all learning together, okay? Even the smartest person that's been in the field talking about refrigerants is learning this for the first time. It's all really new to all of us, so we need to help each other out, educate that kind of stuff. So that's why we're here today with Jackson Systems, okay? Now let's talk about 454B, what that looks like. We got rid of the ozone depletion years ago, things like R12, R22. You see the ozone depletion 1.0, 0.50. We were trying to better that. The first C is your chlorine in those refrigerants. We moved to HFCs. We got rid of the ozone depletion. Unfortunately, we had to deal then with GWPs, all right? In fact, when we moved from R22 to 410A, we actually went up a little bit in the GWPs. You don't know what you don't know. I often compared it, like I did this morning with some training, is, in my opinion, these are Don Gillis's opinions or my analogies, is I remember tearing out asbestos years ago. The mold in the last 15 years kind of became the new asbestos, if you will. We started to bring fresh air into buildings because of mold, became the new bad word, if you will. I think of that when I think about ozone, knowing the history of the ozone depletion, and now with global warming potential. You don't know what you don't know, and now that's the new thing. As I said earlier, that hole in the ozone is almost completely shut, and we can do the same thing with the global warming potential too. And now we're moving from 410A, HFCs, down to HFO blends, to 454B, 466. The maximum has to be 700 set by the AIM Act, okay, in the residential light commercial, so we were able to get way underneath that, okay? What does it look like on a PT chart, Don? Well, it looks like this. Very similar pressure temperature profiles. I'm going to show you here in a little bit up close. Similar thermodynamics, similar material compatibility. In other words, not a lot of changes, or if any, to your components on your TXVs, your coils. You're just going to see that they're stamped. They've been A2L approved. The compressor manufacturers, from what I understand, not a lot of change. You might hear someone say something about, well, we changed the material around the bearings or something like that. But quite honestly, in order to have a fire, you and I both know we need air or oxygen. Those compressors are closed tight in a sealed system. So there's not a lot of, if you go back and even look at some of the old K bodies, that technology hasn't changed for years. If it's not broke, they don't fix it, right? The scroll is still going to be a scroll, and so on and so forth, no matter what refrigerant. In fact, the A2L refrigerant compressors are really just a re-stamped, if you will, of what compressors were before, in my opinion. A2Ls have a lower GWP. As I said, again, it's a 78% reduction just from moving from 410A to 454B. That's huge. Opteon 454B, a 78% reduction, just with that application alone, comfort cooling, okay? So what does that look like up close? I just picked the number. It's kind of generic. This is your low side, obviously, your suction side. You're looking at your evaporator. This is your condenser. I'm going to look at the evaporator right now. I picked around 117 on the pressure. Okay, at 117 PSIG as gauge pressure, for 410A, you'd be looking at somewhere around, looks like around 39.4. For example, on the 454B, you'd be approximately around 44.6. And then with R32, you'd be around 38.3. Typically in comfort cooling, in my experience anyways, you're usually somewhere between 40, 45, somewhere thereabouts, depending on the application and what refrigerant you're using, okay? Application for 410, direct 410A replacement requirement types, ducted splits, 410 units, chillers, PTEX, mini splits, those kind of things. This will be, I'm talking about 454B again. The benefits, again, low GWP replacement for 410A. Again, a 78% reduction in that alone. Let's talk about some of the A2L safety, service, and installation practices, the stuff we're going to be seeing right away. First of all, I made this for as I spoke earlier this morning with Tom Jackson. I made this earlier this year, and I was trying to think the night before I was going to give a presentation down for the HVAC school symposium down for Brian Orr. And I thought, how am I going to get everyone's attention? I was following up two other speakers on the stage, and so I made this up. I know it's very generic, but you'd be surprised how many times this has been shared on different platforms out in the internet. A2L refrigerants will only be used in new equipment. They are not to be used in existing A1 systems. Now, I spent most of the morning or the beginning of this presentation telling you how mildly flammable there was, okay? They are more flammable than A1s though, okay? Even though an A2L is much closer to an A1 than it is an A2 or obviously an A3, there is a small flame propagation there, okay? The difference you're going to see in the A2L equipment, again, just like tools is, it's going to be certified that it's allowed to have A2L equipment. You're going to see the OEMs are going to have like some type of devices in there, some mitigation devices. You'll see sniffers. They're sensing the gas leaks. You might see a low pressure cutout in some application. Depending on the charge and what type of application it is going to be the different mitigation strategies. You'll have a 1, 2, and 3, M1, M2, and M3. The higher the number, the more mitigation strategies you need. You might need to see, go down to solenoid pump down and push the refrigerant outside the building into the condenser. It depends on what that application is, so stay looking for that. But it's all going to be installed at the OEM. You're not going to field install any of this. It's all going to be OEM parts. You're not going to be able to bypass it. It'll be entwined probably in the circuit board or a board outside the normal board there, is from what I'm hearing right now. But to be brutally honest with you, I don't have a lot of information. No one really does right now. We're all waiting for it. They're keeping that information kind of close to their chest right now, but it'll be released really, really soon. So again, you won't be able to bypass it. And you will only use OEM parts, okay? You won't be able to bypass it. But only use the A2L refrigerants, please, 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 in the newer equipment. There are no hydrocarbons in A2L refrigerants. I know that sounds simple, but you'd be surprised how many times somebody tags me in a post or something, and just to kind of bring some information in, like others, to share the knowledge of what A2Ls. There is a huge misconception out there, and I travel quite a bit throughout the nation, and it's not just one spot geographically, it's everywhere. And you could have 20, 30 years experience at a wholesaler or a contractor, and it's all new to you, so you don't know. You hear something, there's a lot of stuff on the internet, most of it's good. You really have to check your resources and make sure you're listening to from somebody like a refrigerant manufacturer like Chemours, for example. Okay, what are those new tanks going to look like? We've always used colors in the past. They're getting away from colors. If you haven't already saw it, you've probably already seen this because I see them everywhere now. They're going to just an off gray color for the tanks on the A1 refrigerants. On A2Ls, they'll be an off gray and they'll have a red band around them, okay? Signifying that is an A2L refrigerant. So that's one thing you'll notice right away, okay? Why did they get away from colors? Quite honestly, the best information I've received, and there's quite a few things that came into factor here, but the biggest one to me for the contractor is they didn't want to go down the road 5-10 years from now and make an A2L refrigerant and put it in a tank that was slightly off green compared to this. You have a lot of new technicians out there for fear that they might grab. That's the biggest reason for me to look at it. So you have the red band around it. What else will you have? When it comes to the truck, it's going to be pretty much business as usual, safety, installation, and service. Same PPE as we used before, nothing special there on that. There'll be a lot of things like purging the lines. I'll talk a little bit about that here in a little bit on the trucks. They did just test the A2Ls to lay on their side for that protection of that disc or pressure relief that we're going to be talking about here in a little bit. And it did pass. It just needs to be, it's resubmitted now to be approved. I didn't know actually, and maybe you didn't know either, that actually states on the box on A1 refrigerants that you should keep them upright. It says that on the box, which you and I all know that refrigerants don't typically stay in the box very long when you're a technician. It's not the real world. We usually have them set up like this. So that's really the reason I put that picture in there. This is actually the slick that came out. That's actually the tank of the 454B. What it looks like, that's the original prototype. So, service vehicles. Under the materials of trade, it's business as usual, as I said earlier. Same restriction in place, 440 pounds maximum, regardless of the hazard. That's obviously not one container, maximum in a truck. Federally, there are no placards required for service vehicles. However, for transportation, there will be, okay? So stay tuned on that for the DOT. What's new? So this is really kind of the meat and potatoes right now. A2L cylinders, will have that red band around them. Not too long ago, the beginning of this year, I was showing two pictures, one with this all red from the red band up and one with a red stripe, because we just didn't know how that was going to shake out. They decided with the red stripe. That's one. The other one is on your DACs, your disposable tanks, they will be left-handed threads, okay? And the reasoning for that is, again, all about liability. It's not just us, Chemours, it's also our competitors, okay? And we're used to left-handed threads on automobile refrigerant and that kind of stuff already, so it's not the end of the world. And really what it is I travel a lot, I see a lot of contractors, I train a lot of people, and I have for years, all over North America. Like any other industry right now, there's a lot of labor shortage. We're no different than that, obviously, and sometimes worse, okay? The reason I tell you that is a lot of times you start out in installation, then you go to preventive maintenance, and then you go into service. Okay, you work your way up, but it takes some time to get there. Unfortunately, with the shortage in help, what we're seeing in our industry right now is sometimes, like any job, we're getting put in positions that we're not quite ready for. So getting back to the left-hand threads, there'll be an adapter. You'll have to take that adapter and put it on that left-hand threads, turning it back into right-hand threads. the hope is that if somebody's fairly new to the industry or they just got put in a truck to run service, even if they've been around preventive maintenance for a while and they go to put their hose on, it doesn't work, maybe they'll make a call either to the service manager or back at the office. Hey, I don't mean to sound silly, but I can't get my hoses on there. The hope is that someone will say, does it have a red stripe on it? And they'll say yes, and that will stop that, okay? So again, it's all about liability, and when it gets to the OEMs, it'll be the same thing there. They'll have their mitigations in there, their strategies in there, and it's just about liability covering that. So red stripe is an indicator, left-hand threads is an indicator. If you put that adapter on, you're knowingly working with A2Ls. You shouldn't not put it in an A1 system, okay? And then last but not least, we're gonna have some shrink wrap around the top of the port, the service port. Okay, and what that's going to do is let you know that that's been tested and it's high quality refrigerant from a good manufacturer, and it confirms that what we say is on the label is in fact in the tank. Okay, what I mean by that is there's a lot of things that come in that are not checked to the stringent as we do, as some of our competitors do, and we find that we have different chemicals in there that aren't even supposed to be in there. Some of those might be something like similar to R125 with a very high GWP. So this again is all about covering our bases on that high GWP refrigerant, confirming that we are putting good quality stuff, that the EPA is aware of it there. Okay. Let's talk about the cylinder safety valves. In the past, we've used a rupture disc. If you don't know, this ruptured disc is there for a reason for high temperatures. So using your truck as an example, if you were down in southern Florida or Alabama or somewhere like that, and it became hotter than 130 degrees in the truck, or anywhere for that example, if it gets somewhere thereabouts above 130 degrees, let's say, the idea of that is the ruptured disc is to pop and release that refrigerant. It will release all the refrigerant. That's how the ruptured disc works, okay? When we use that tank also, to finish that story up on the ruptured disc, you are to remove that ruptured disc or poke a hole in it, decommission that tank so someone doesn't come along and hurt themselves. So really, it's all about so this doesn't turn into a giant hand grenade. That's with the ruptured disc. So staying with that safety device, moving to A2Ls, even though we've played that down, that lower flammability or mildly flammable thing, we're going to go to a relief valve. Again, it's all about liability. We have a red band. We have the left-handed threads. Now we're going with a relief style valve. And the way the spring-loaded relief works, the CG7, is basically, as you know, any relief valve does, it lets just enough pressure to keep it in the safety zone of the tank. So the fact that it is mildly flammable, they've even been taking an extra step to relieve that refrigerant, not blow the whole charge, just enough to bring it into safety and keep the tank and not blow the whole charge. So not to let as much refrigerant in the truck there. And quite honestly, I've never seen that happen in Ohio, where I'm from, or Indiana, or anything like that. But if you go to the southern parts of the states in the nation or Latin America, those ruptured discs do go off, so that will come into play. So another safety feature that not only us, but our competitors are using on the A2L refrigerants. Now, this is a very rigid compared to this, where you could puncture it, so you won't be able to puncture a hole in there or remove that. You'll want to use a non-sparking device and poke something in the center there, right about center point of that. And these are, again, disposable tanks, as we talked about. Okay. As far as charging, 454B will be the same thing as 454 or 410A was. It's the same thing as before. It's a blend. It has two components, a blend by definition, two components or more. In the 454B, we have R32 and 1234YF. In the 410A, we had R32 and R125. So nothing's really going to change that. Same old as far as what we did in the past there. So, and I get that question a lot, like what's going to change as far as brazing, charging, those kind of things. And it's funny, I saw an article the other day that I wrote 4 or 5 years ago, just a brief story here, and it was about A2Ls, and it amazed me how much of that article, and I can't remember where it was published at, but it still holds true today. And multiple times I say in that article, it's going to be business as usual, getting back to the basics, and that's really what a lot of this is. Some of the things we should have been doing, we're going to now be required to do, okay? So, for example, here, A2Ls. Notice the red here. We're going to be required to purge the circuits. After you cut a circuit open, If you're working on an A2L system, not an existing A1 system, if you're working with an A2L system, it was good practice before, and I'm not talking about brazing, using nitrogen while you're brazing to remove oxidation. I'm talking about when you cut the lines open, you're supposed to purge those with nitrogen to remove any possible residual, refrigerant that's in the line. With A2Ls, that's going to be required now, okay? When we move into evacuate the circuits, that's going to be required. You're going to evacuate that circuit after you break that open, all right, or brace it back in. Also, leak and pressure test, that's required. They're already starting this in California, okay? They're documenting that information, kind of like we do with natural gas lines now. If you've ever ran a lot of gas line, whatever municipality you're in, they make you hold that gas line pressure, or the building department is, for so long. We've been doing that for years. It's going to be the same thing. That's going to be documented. You're going to have to pressure test that and then hold that, which you should have been doing already, but now it's just going to be documented, okay? When we get into tools, most of the common tools used today, especially hand tools, are going to be same as we use for 410A, okay? There's really not a whole lot of anything exciting there, besides the electronic stuff, your vacuum pumps, your recovery machines, and those kind of things. And what I've been telling everyone is we need to go to the manufacturer's website, check your model number. As I told some people earlier today, is unlike new cars where they make a new model every year, they don't make new recovery machines every year. It's not that they don't make a new recovery machine on a certain year, but typically those models stay in the field for quite some time. They may make something that's, a little nicer or oilless or something like that, but for the most part. So the reason I'm sharing that with you, I was a contractor, started out 31 years ago. Like I said, I know that money can be tight sometimes, especially when you're first getting in the field. I wanted to make sure that you're aware that you don't necessarily have to go out and buy a new recovery machine and replace the one you just bought last year or 2 years ago, okay? They tested the older models that are still the new models. In some incidents, check again your manufacturer, your model number. I don't speak for all, okay? But I've heard through the grapevine that basically they've tested these things, they've passed the test, and that is as long as you don't modify anything. So if it has an OEM switch on the recovery machine, don't try to bypass that or rig something up your own way, okay? But check with the manufacturer. A lot of information, everything if you buy anything new right now, make sure it says that it's been A2L approved. But if you have something like a recovery machine, it doesn't mean it's not approved. You need to go check your model number. You might be pleasantly surprised. On vacuum pumps, really, really check that, okay? On vacuum pumps especially, make sure that there's no spark or anything. Again, use only vacuum pumps designed to pull a deep vacuum, use a micron gauge, and use a vacuum pump rated for A2L refrigerants, okay? That is a big one right there. Please, please, please check with your manufacturer. Wherever you buy from, whatever wholesale you buy, whether it's from Jackson Systems or another wholesaler, check with your manufacturer. You'll start to see a lot of counter days, more than likely, from what I hear. Some people are already offering, if you send the equipment in, like a recovery machine, if you want it recertified, they'll go through it, change the O-rings and those kind of things. But for the most part, it's business as usual, but check with your manufacturer, okay? That does not hold true for everything, all right? Double check. I put this in here only because I get asked a lot about brazing. And the biggest one for me for brazing is still going to be the same way as it was. We need to use that nitrogen. You have to make sure you purge those lines and keep that residual refrigerant out there, okay, before you start to hook everything back up, okay? Be very, very careful around that, all right? So it wouldn't be a bad idea to have, especially with propane, obviously, we want some kind of a refrigerant sniffer out there while we're working with that. That's a staple with R290. A2L, not so much, but would be a good idea to have something out there to check to make sure you don't have anything in the air. But again, as I said earlier, the further it gets away from the actual flame, if something were to ignite on A2Ls, like oil does, it stays fairly close until it gets out, and the more air you add, the concentration's not right, okay? As far as the tools, as I said earlier, some things are going to be obvious. Your scales are going to stay the same. Again, gauges, when we come to compound gauges, obviously if it doesn't have 454B on the gauge, you'll have to buy gauges that say 454B, even though the pressure and temperatures are really close. you'll have to make sure that it says that 454B on there, or R32, whatever you're using. So when you go to digital, a lot of that stuff is Bluetooth now. Those apps will already have the 454B or R32 on them, and that will be set up already, so it'll be engaged in your app on your phone or whatever software you're using on that Bluetooth, or whatever brand you're using in that area, okay? For the most part, again, move to A2L compatibility for recovery. Gas detectors, again, 2Ls, make sure your sniffers. Again, a lot of this refrigerant that's in these A2L blends, these HFO blends, are refrigerants that were already used in different applications. They're just blended together now. So you might find that that's already on your sniffer, but double check on that, okay? Make sure, for sure. Again, move to A2L tools from this day moving forward if you haven't already, and I know a lot of you have. I've been seeing A2L stuff, tools and what have you, being sold for at least 2, maybe 3 years now. We all knew it was coming. Today, it's here. It's literally here, okay? This is just some examples of some of the stuff you'll find on some of the websites. I'm not affiliated. Chemours is not affiliated with any of these brands. Okay, it's just some examples, and every time I'm out in the field and someone says, hey, we have that too, I put another one on there. So I'm trying my best to fill it up as fast as I can. But these are just examples of some of the companies that already have posted out there and have for years of some of their equipment that's A2L approved. Check your model numbers and see if the one you recently bought isn't already approved, okay? Some of the resources we have, if you would like to stay up on A2L stuff, we have a very nice newsletter. Again, go to Opteon.com. Again, Opteon is our trademark name. What used to be Freon is now Opteon. Go to Opteon.com. Everything on there is free. Great information, videos, training, tech support, all kinds of stuff. But getting back to this newsletter, A2L Refrigerant newsletter, goes out about every 2 weeks. A great information. It won't overwhelm you. It goes in the email. Hey, the worst scenario, if you don't like it, unsubscribe, okay? But it's free. If you can use that QR code, it'll take you right to it. Here's another QR code that'll take you right to the Safe Refrigerant Transition newsletter for AHRI. Another great resource. Lots of webinars on A2L refrigerants and some of the things that are changing. Again, make sure you're focused on that A2L and not the A3. Again, apples and oranges, completely different on there. If you want to go to their website, Safe Refrigerant, that's the QR code for that. Again, can't emphasize enough, great resource. Okay. Finally, the last slide for Chemours, Tech to Tech, 1-800 number. We also have the Tech to Tech at Chemours.com. Great information at Opteon.com, as I said earlier, all kinds of stuff, kind of like a did you know, fun fact type stuff. We also, Opteon.com YouTube channel, good friend of mine, very knowledgeable, Dr. Chuck Allgood. It's called Check Up with Dr. Chuck. I love them because they're really short. 1 to 2 minutes, minute 45 seconds, really easy to digest before you start your day or end your day. If you want to know something, you can pick out what you want to listen. If it says, hey, what did you know what an HFO was? I think they're in their 4th year now. Good stuff. And I always like videos that are about a minute or 2 long or less than, that you can easily digest and go about your day, okay? All right. And Chuck does a great job of explaining things in layman terms where I can even understand it, okay? So that's it for me today. Thanks for tuning in. If you want to reach me, if I can help you in any way, you can reach me at don.gillis@chemours.com. And I appreciate your time, and I want to thank Jackson Systems for having me today. Chemours really appreciates it. So be safe out there, be kind, and we'll talk to you next time.